Our lecture name is light. It is a 10th class. Uh, all importance term, all importance concepts will be covered in this lecture. My name is written over here. It's me. Uh, Background behind me is showing what are we going to discuss. This was the first slide. In this slide, you can see what is the name of your lecture and who is this. It's your instructor. Standard is a 10th. Standard is a 10th. Now let's start with the definition of light. What is light? Light gives us as you know in our language, that it is a light which gives us a view. Whatever is possible to see because of light. Light will fall on the surface of the object, then our eyes are able to see the object. That is how we realize light. Light is what we are able to see anything. Light is a form of energy which helps us to see objects. Yes, without light, everything will be dark surrounding you. Everything without light. When light falls on an object, it reflects the light, and when the reflected light reaches our eyes, then we see the object. This second is a process of how do we see a object. When light will come from a source light, then that some lights will fall on the surface of the object. Then in the another direction, some lights after hitting the surface will reflect, and that reflected rays will reach to our eyes, and that is how we see any kind of object. Any object light travels in a straight line. Yes, it is also truth. This is a fact that yes, light will always travel in a straight line. You can turn a direction of light, but remember, this will always light will always travel in a straight line anyhow. And this will not be unstraight, it will not be a curve, only straight. Fourth, we have the common phenomena of light are formation of a shadow. Yes, sometimes no. If you take a opaque object and you should have two or three objects to observe any kind of any shadow of a object. Then you should have more than two things. First, you can have a object which should be opaque object, because we are going to form a shadow. That's why. So here, first you should have a opaque object. Second, a source light. Source light will emit their own light. That's why source light will be compulsory. Why? Because of formation of a shadow. Now we want to form a shadow. That's why light is a compulsory. Light source is a compulsory. Now next, if you wanted to see a shadow of an object on a screen, then you should have a screen object, so that you can easily see, so that you can easily observe the shadow of object. So now in front of there put a source light, and in front of a source light just put a opaque object. Then turn the switch of you turn switch into on mode of the source light. Then that light should fall on the surface of the object. Now it will reflect into another direction, and then this opaque object will form shadow. Remember, it is forming opaque object will form shadow because of it blocks the light. That's why opaque object blocks the light. That's why it forms a shadow. Okay, till here it is clear. Formation of images by mirrors and lens. It is possible to see any kind of images inside the mirror, because of when light falls on the surface, then falls on the mirror, then it turns into another direction, and then after reflecting rays after reflecting rays from the surface of the mirror, it hits this surface of the object, and then image of that object will be formed inside the mirror. This is how a image is formed by mirrors when light is falling on a mirror. Then bending of light, it can also be observed. Bending of light, it will be possible when you will have a object which should be transparent by a medium. Twinkling of stars, you realize the twinkling of stars in the sky. This happens because of a reflection of light. That's why you are able to see twinkling of stars. Next, we have a formation of a rainbow. This is also possible because of a reflection of a light. In details, you will understand it in separate lecture. But this is just an example of a reflection of a light. Formation of a rainbow we see because of reflection of a light. That's why we see formation of a rainbow. In this example, you can realize there is a source light, which is a torch. Light is coming from this source, not from this source. Some lights are falling on this object, then it is turning into this direction. That's why this is reflected rays are reaching to this eyes, and he is able to see. Now he is able to see this object because of light fall on the surface of this object, then it will turn into another direction. This is process. Now in this, what is happening here? This light will come when electricity will be provided to this electric bulb, then it will glow. When it will glow, then we will be able to see anything which will be surrounded of this. Now ahead of this, we have 4 figures to visualize. In this, what is happening? A light is coming from here to till here. Remember this ray, this beam. What's the difference ray and beam? What's the difference ray and beam? Ray is just a one, and beam is a collection of rays. This is what is the difference between them. Here we have a collection of rays. That's why you can call it also what a beam, because of it is a rays of light. That's why. So it is coming, and now this is what a mirror. As you know, behind the mirror is painted by color. That's why this is known as opaque object. Rather than saying it as what transparent, they will call it opaque object because of coated area. Now light will come. Whatever light will come from the source light till the hitting of the surface, from here to till here, this will be known as incidence ray. And after the hitting into another direction, and this is going into another direction, this will be known as reflected ray. Now what is the angle of incidence and what is the angle of reflection? Here remember, from the incidence ray till the normal, we take normal line so that we can calculate. This normal line will be imaginary line. We are imagining. So we take normal line as a imaginary. So remember, from the incidence ray till the normal line will be called as a angle of incidence. Same here, from the reflector ray till the normal line will be called as angle of reflection. But remember, from here to till here, this will be something else. When question will ask what is the angle between a surface of the object and a reflection and reflected ray, then this is what you will have to tell. In details we will see this. Don't worry. Calculation. There are some questions based on this concept. Now next we have this figure. In this figure, what is happening? Here you can see this is here and it is bending. Here this is looking strange. So it is possible because of medium, because of medium. And here we took a glass which is a transparent. It is a more possible when we will take, it will be more possible when we will take a transparent object, then it will be more possible. Now we have this. Here you can see this is bending. It is going like that, but it is not going, actually it is not going directly. This is here and it is here. This is here because of this, from here to till here it is in air medium, and from here to till here this is in water medium. This is the main reason for happening this. Same with this, from here to till here this is in air medium, and from here to till here this is in water medium. Always remember, light will travel more fast in air, light will travel less in liquid material, light will travel speed of light will be less as compared to in air. What about solid? In solid, this light cannot travel in solid. Light cannot travel in solid. So remember, in air, a speed of light will be more, and in liquid material, a speed of light will be less. Here we have a rainbow. We can see a splitting of one color, a splitting of a white color. This is 7 colors of one color. And details about a rainbow we will take a separate lecture when we will be understanding a splitting of a white color. Then you will have clarity about this, how does it happen. Now we have this white light is going in this white light is coming in this, and it is falling on the transparent prism object. Remember, this is a transparent object. Light is coming and it is falling on the surface of the transparent object. Now this object will split this white light into 7 except white. So this transparent is splitting this white, and all the 7 colors are here. You can read it. So remember, intensity of red would be more and intensity of violet will be less. This would be more and this would be less. So a splitting of white color would be always 7 colors. Here you can realize 7 colors. Now we are able to move ahead. In the next we will explore it in details. Reflection of light. When light falls on a highly polished surfaces like a mirror, most of the light is sent back into the same medium. This process is called reflection of light. In some words, in one sentence, in 2 sentences, you can understand the meaning of definition of a reflection of light. Just you can say that bouncing back of light. This is what in some words the meaning of a reflection of light. You can extend this by saying a incidence ray which falls on the surface of the object, then it will turn into another direction. This turning of the incidence ray after hitting the surface will be known as reflection of light. That's it. This was in our language. Now next we have laws of reflection. There are 2 laws of reflection of light. 2. First of all, angle of incidence will be equal to angle of reflection. Whatever will be making angle of incidence, for example 45, angle of incidence is 45. So angle of reflection would be same, 45. Here, this was the first law. We will visualize it, don't worry. Next we have the incidence ray, the reflected ray and normal light. We have discussed what is the incidence ray. This is the incidence ray. Incidence ray is a ray which comes from the source light, and this reflected ray is a ray which comes after the hitting the surface. So this incidence ray and this reflected ray and the normal line, this normal line to the mirror will lie at a plane mirror. This will happen always. It is what a second law. This is second law of reflection of light. Now let's visualize it. As I told you, what is the angle of incidence from here to till here? This will be known as angle of incidence. From here to till here, this will be known as angle of reflection. Here we are taking incidence. So here we are taking incidence. From this word, you are sure that here, from here to till the imaginary line, this between this, what is with how much angle is this forming? So this is forming 45. Let's say 45. So this will be also 45, and this line will be perpendicular. This side when it comes to perpendicular, this side will make a 90 degree, and this side will make a 90 degree when it will come to perpendicular line. This is working as a linear pair. This is performing as a straight line. As you know, sum of this and sum of this, so sum of this would be 180. 90 plus 180. So here a question can ask what is the angle between a surface of the object and reflection ray. So don't say this, say this, instead say this. This is what a question is asking. Now in this, what is happening? We have a normal incidence ray and mirror. This is plane mirror. Both are same. Okay, you are crystal clear. Now we are able to move ahead. And this, what points can be visualized? The image would be erect, which means as it, nothing would be changed. One thing is a change point. We will say it. Don't worry. So image would be erect, as it. Size of the object and the inside the mirror would be as it. Nothing would be changed in order to see the size of the image. The image is the same size as the object. For example, this is the original object. You know that this is the original object and this is imaginary object. This is what inside. This is the image which is inside the mirror. Now here. The image is as a size. It is telling you here we took a plane mirror. This will happen with a plane mirror. With a concave mirror, with a convex mirror, something else will happen. Plane mirror will give you always a erect image, a same size of image. Size of object would be same. Size of object would be equal to size of the image. This is let's say 5 inch. So this would be also 5 inch. It will happen with a plane mirror. The size is at the same distance from the mirror as the object is in front of it. In front of this is mirror, and between this original object and the mirror is something different, something distant. Let's just say 5 meter. So same here, behind this with between the image and this mirror would be same 5 meter, because of we took a plane mirror. That's why. Next we have the image is virtual which means imaginary image virtual. When it will come to imaginary image, when it will come to virtual image, then to be sure to make sure that images will cannot be projected, cannot be obtained on a screen, because of this is imagery, it is not real, that's why. So virtual is not a real, it is a virtual imaginary, cannot be obtained on a screen. The image is laterally inverted. What is the meaning of all this? Laterally inverted, which means this left hand of my body, this left hand will appear in the right side of, in the right side of the image inside the mirror. Same will happen with this. This right hand will appear in the left side of inside the mirror. This will happen, and this phenomena is known as laterally inverted. One thing more I would like to add is that what if you have a text can be on a book, text can be printed on your t-shirt. If you are in front of a mirror and text are printed on a shirt or a t-shirt, then this printed words will appear inside the will be strange. Letters, words will be in strange manner. This is what laterally inverted. This is inverted. This is what is inverted. This is done. We are able to move towards this. Now next we have aspherical mirrors. From a spherical mirror, we will take two kind of mirror. First of all, let's see what is a spherical mirror. This is important to understand how does it look. A spherical mirror is a curved mirror, which is a part of a hollow sphere. Spherical mirrors are of two types. They are concave mirror and convex mirror. It looks a hollow sphere like this, and when we cut it at the medium, then we get two kind of mirror. First will be concave and second would be convex. Remember, you will have to cut from the medium, at the medium of the spherical mirror, then you will get two kind of a mirror. First would be concave and second would be convex. Let's see, and these two mirrors are getting from a spherical mirror. Remember this point. First, concave mirror. Remember, we have cave. When it will come to cave, then you in your mind should come one thing, which is what? Inward surface will be reflecting surface. Inward surface will be reflecting surface. This is what? Concave mirror. So it is a spherical mirror whose reflective surface is curved inwards. This is curved inwards. This is the inward, and this would be reflecting surface. From cave word, you can remember this. Cave is what? Just inward. Cave is just inward. Rays of light parallel to the principal axis after reflection from a concave mirror meet at a point, converge on the principal axis. When it comes from a source light parallel to the principal axis, then it will meet to the focus. Next we have convex mirror. From vex you can remember it. Vex, which means outward surface. Outward surface would be considered would be considered as a reflecting surface. So this is outward surface, this is what outward surface, this is inward, this is inward surface. So when a parallel ray will hit on the surface of the convex mirror, then it will diverge. It is a spherical mirror whose reflective surface is a curved inward, convex, curved inwards. This is curved inwards. A reflecting surface. Rays of light parallel to this principle after reflection from a get diverge and appear to come from a point behind the mirror. Here remember this would be outward. This would be here would be outward. Remember. So this is done. In this we understood what is a spherical mirror. When we will add this and this both will give a spherical mirror. Now these two parts of a spherical mirror, we took this from a spherical mirror as well as this part from the spherical mirror. Now remember, inside inward surface will be reflecting surface, inward surface will be reflecting surface. This kind of reflecting surface will be known as a concave mirror. Convex mirror, this outward surface will be reflecting surface. Here when a light will come parallel to the principal axis, then it will meet at the focus. When in the case of a convex mirror, when light will come parallel to the principal axis, then it will diverge. It will not converge. Concave mirror will converge and convex mirror will diverge. Like that. Now it is done. Next, we have terms used in the study of spherical mirrors. First is center of curvature. This is just a radius. This is just a diameter of the spherical. Curvature is what? Diameter of the curvature. That's it. You have to understand about the center of a curvature. It is the center of the sphere of which mirror is a part C. For example, here this center, this radius would be known as curvature. This not this side. This would be known as a curvature of this spherical mirror. Now we have next radius of curvature. It is the radius of the sphere of which the mirror is a part CP. Where is the CP? From here to till here. From here to till here, this will be known as CP. This is what is the radius. From the center till the pole. From the center till the pole will be called as a radius. This radius, and focus is just half of radius. This focus is a double times of a radius. 2f is equal to r. 2f is equal to r. So remember, C is the center of a curvature. This is the center of a curvature. From C to P, this would be considered as a radius. So from here to till here, this would be focus. It is just half of the radius. Now next we have a pole. Pole is the center of the spherical mirror. So let's see, where is the pole? This is pole. So this center of the curvature mirror. This is what? Pole. This would be considered as pole. Now next we have principal focus. In a concave mirror, rays of light parallel to the principal axis after reflection meet at a point of the principal axis called principal focus. Concave mirror. This is a concave mirror. This is concave mirror. Always remember, when a light will come parallel to the principal axis, then it will meet at F. Here it will meet. Okay. So it will happen when we will take a concave mirror, then this will happen. If you take a convex mirror, this will not happen. A parallel ray will not meet at a focus. It will diverge in the case of a convex mirror. Now next we have a principal focus. So where this this is a focus, this is known as principal focus. This is a principal axis. This would be considered as principal axis. Now it is done. Next we have, in a convex mirror, rays of light parallel to the principal axis after reflection get diverge and appear to come from a point on the principal axis behind the mirror called principal focus. Let's see. It is saying, when we will take a convex mirror, then of course a light will come, then it will hit this outer surface of the convex mirror, then it will diverge rather than converging. It will diverge like that, and then a pointer will go from here to the infinite bypassing the focus. This would be imaginary. AXY, here AXY is what? Principal axis. CP is what? Curvature. This is the radius. CP is the radius of a curvature. PF is a focal length. PF is a focal length. That's it. Now next, focal length. This is done. So R is 2 times of focus. And focus, how to calculate focus? To calculate focus, there is a formula which is R upon 2. Now we are able to move. We visualized this. Again you can see, I am going to repeat it again. Remember this, in a spherical mirror, from there would be a diameter from the circumference, from a point of the circumference till the another point of the circumference just front. This would be considered as this diameter line would be considered as the center of a curvature. Not center of a curvature. Yes, center of a curvature. Principal axis. This is the pole and CP is the radius. FP would be focus length, PF. Now this is done. Reflection by spherical mirrors. Reflection. Let's visualize reflection. In a concave mirror, when it comes to concave mirror, a reflecting surface inward, so of course it will converge. The ray light will be converged. This is a concave mirror. Now here a light is coming which is parallel to the principal axis there. So here we took a concave mirror, that's why this parallel ray will meet at a focus. In a convex mirror, this ray will come parallel to the principal axis, but it will diverge rather. Now here there is one thing will happen which is imaginary. This is imaginary point from focus till the here. This is what will be imaginary, and this is known as a image. This is known as image. This was about in this we have discussed it. Just it was repeating. Now next way. In concave mirror, a ray of light passing through the focus. A ray which is coming from source light, it is passing through the focus. Firstly, we will realizing that a ray was coming which was parallel to the principal axis. Now we are realizing that a ray which is coming from the source light is passing the focus and it is hitting the inward surface. Now when this light will come like this, then it will be parallel after hitting the inward surface. So in a concave mirror, a ray of light passing through the focus after reflection goes parallel to the principal axis. This is just opposite. Here we realized this was parallel and it went like that, not parallel. Now here we are realizing this came not parallel, and it became parallel. It came like that, then it became parallel after hitting the inward surface. Now here, same here. In a convex mirror, a ray of light directed towards the focus here, like that. It will what will happen? This will diverge like that. This will become when a ray will come which will be non-parallel will become parallel after hitting the surface, and here would be a imaginary image. It will emit this imaginary line will emit at a focus. Now this is done. In this we can realize one thing: in a concave mirror, a ray of light passing through the center of a curvature, what will happen in this case? Then after reflection is reflected back along the same direction. This will take back a step. This will turn into back. This will be same direction, like that. It will happen when a light will pass the center of a curvature. Then it will come in the same direction. Same in a convex mirror, a ray of light directed towards the center of a curvature. After reflection is reflected back along the same direction. This will come in same direction as it was going in a direction to hit on the surface of the convex mirror. In this you can see, here we are realizing that in this we are getting real images. In this we are getting imaginary images till now. Now next, in a concave or convex mirror, a ray of light directed oblique at the pole is reflected oblique, making equal angles into the principal axis. What is here? A ray is coming which is not a parallel. This is coming and it is hitting the pole. Now what will happen? Same here. What will happen? This angle of incidence will be equal to angle of reflection. This is what will happen. It will happen, we will get angle of reflection is equal to angle of incidence. This will happen when a light will be hitted on the pole of the concave mirror. It doesn't matter you take if you take a concave mirror or convex mirror, angle will make the same. This would be equal to this, and as you know, this is an imaginary line. Same here, this is a diverging. This is a diverging. Now this is clear. Next, we took images formed by concave mirror. Now let's see what is images. When the object is at infinity, which means very far. A object is very far from the a mirror, then what will happen? Let's see. When the object is at infinity, here, this object is over here. At infinity, the image is formed at the focus. Then what will happen? A light will come like that. It will go parallel to the principal axis. As we saw that it will meet at the focus. This will happen when a object is far away. This object is at infinity. Then this will happen. Then the reflection ray will meet at focus. Now next we have when the object is beyond C. Then what will happen? The image is formed between C and F. Where C and F, curvature, between curvature and focus. Here object will appear here. This is what laterally inverted. This would be laterally inverted. So size it is a small as compared to this. So remember, if a object is beyond C, uh, then image would be between C and F. Image would be between C and F here over here. Wherever you are saying interaction view, then at that interaction view, image will appear. The image is formed between C and F. It is a diminished, which means a small, and a real. This is real because it is not inside the mirror. This is in front of mirror. That's why it is a real. And inverted, it is just opposite. Inverted, opposite. Opposite is inverted is just opposite. Inverted is considered as just a opposite. So this is the diminished. This diminished, which means a small. It is not too much a small, but it is a small, and this is a more big as compared to this. This is inverted. It is not a virtual because it is not making inside the mirror. That's why it is a virtual. It is a real. Now we are able to go ahead. Now next we have third. When the object is at a C, which we are putting an object at a curvature. We are putting an object at a curvature. The image is formed. The image will be formed at C. Same. So here can we say size of the object would be same? Would be same? Easily we can say. Confidently we can say, because it is distance is the same, or size would be same. Size would be same. So remember, when a object is placed at a curvature, then real image will be at curvature. And size would be same. It will happen with this only. It is the same size as the object, a real inverted. Yes, this is just opposite of this. This is inverted. Now clear. Now what about a object which is between C and F? In that case, let's see. Now object is between C and F. When the object is between C and F, the image is formed beyond this C. Then image which would be real would appear beyond this C. It would not be at infinity, but beyond this C. When object is between C and F, it is enlarged. It is a more big as compared to this. That's so reason behind this is what it is here, and this is going here, this side. So this is becoming large, and this is becoming a small. Here it was large, and slowly this became a small, and this was here, it was here a small, and slowly it is becoming large. As we are placing this near to this mirror, it is becoming small, and this real image is becoming large. Okay, now this is clear. Now what about if this is at the focus? Then what will happen? Then either it would be a real image would be at infinity. Let's just say yes, infinity, at infinity. This and here, and another is over here. So image would be at infinity. You can say magnified. Here it is magnified, and image would be real, yes, and it would be inverted, enlarged. Is very high enlarged. This is done. Now next you have when the object is what if object is between f p, then what will happen? In that case something else you will realize, and it is a different from the previous discussion. When the object is between f and p, between this f and p, then image is formed behind the mirror, then image will be formed behind the mirror. Now this kind of images will be known as virtual images, because of it is inside the mirror. That's why this will be known as virtual. And here this is what large and it is a small. You can say in size there would be changes. It is enlarged, virtual and erect, not literally inverted. It is not inverted. This is erect, as it, nothing is opposite. So this is what is the first case which will happen in this like that will happen. In this we are realizing that we are getting a virtual image instead of uh, getting, rather than taking what real image. Here we are getting virtual image because of a object is between f and p. That's all. Uh, whenever object is between f and p, then of course you will get a virtual image. Now it is done. Ahead of this, let's see images formed by convex. Let's see in this way. Now we have at infinity, the object which is at infinity. We start a object which is at infinity. When the object is at infinity, the image is formed at f. This is parallel. Okay. Same here. This will happen as we saw in the case of concave mirror. Same here. Something will be similar, but something will be different. When the object is at infinity, the image is formed at f behind the mirror. Here you will see what this is going at infinity. It is not touching this. It is not touching this. That's why this is not touching the principal axis. There is no intersection view. You can see there is no intersection view. Here after hitting the, there is no intersection view of this reflection rate. That's why it will be traced. It will be traced. It will be stretched so that it can show a imaginary image. As you know, when a light goes parallel to the imaginary line, then it diverges like that, and this will be stretched and it will emit at a focus. No, it is a highly diminished. This is very diminished and virtual. This would be virtual here. Image would be over here. Image is over here, and it is erect. We highlight image, which means very small. Now we will place a object at beyond C. Then you will realize that object is image is between F and let's see. Now our object would be beyond C. Now when the object is between infinity and pole, here between infinity and pole, in that case the image is formed behind the mirror. It is diminished behind the mirror. Yes, Okay, because it will form in image which would be which would be behind the mirror. Because of it diverges, that's why it is a diminished and it is a diminished virtual and erect. A virtual which means the image is forming inside the mirror, that's why it is a virtual. It cannot be obtained on a screen and erect as it nothing. This would not be inverted, not opposite. So here you can see this is diminished, not highly diminished but diminished. Here we can observe object, but in the previous here we cannot observe object at all. That's why here there is a word which is highly diminished, very small. There is a very small object, which is why, because of object is at infinity. That's why here inside this we can see a little image of this. In this case, the object is between the infinity and pole. That's why we can see a small size of a object inside the mirror, and it is between the between the P and A, between the PA. In the previous we were realizing image is forming at focus, and here we are realizing image is between between F and P. Now this is clear. Here, uses of spherical mirrors, concave mirror, concave mirror. Remember, concave mirror is used to see anything which is very thin, to see tiny materials into a small into large view. That's that's why concave mirrors are used. Why? To see a tiny object into large view. Concave mirrors are used in torches, searchlights, and headlights of vehicles to get parallel beams of light. Here you will see that this will go like that, this will go like that. It goes like that because of concave, because of it converts, then it diverges. They are used as a saving mirror to see large images of a face. Yes, they are used by dentists to see large images of their teeth. Yes, we will realize that yes, convex mirror can cover a lot of area, a lot of area. Convex mirror. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnace. Remember, if you have a large concave mirror, then you can convert a sunlight to burn anything, to convert sunlight into electricity, into electricity, into electricity. So you can use a concave mirror to convert what uh, sunlight. If you use a convex mirror, then sunlight will not be instead it will diverge. Convex mirror. Now we have convex mirror. Convex mirror are used as a rear view. It gives you a large view behind the vehicle. This rear view is used to see a large view behind the car. That's why it is used. Convex mirror give erect diminished. It will give you as it, not inverted, as it, and diminished images of object. Objects would be diminished. That's why it covers a lot of area. They also have wider field of view than the planar beam. Yes, it is a truth. It is a truth. Now we have a new Cartesian sign convention. New Cartesian. Look at here. Look at here. What is it saying? Can you tell me? Here, new Cartesian sign convention for a spherical mirror. The object is always placed on a left of the mirror and light from the object falls from the left to the right. There is a object directed to incident ray distance towards the left. This would be negative and this would be positive. This would be positive. This is what is a height upwards. This is a height upwards. This is side distance. This is side positive, and this is what is a height downward. Downward would be negative. This will be useful in a numericals, in solving numericals. We will take a object and height of the object would be positive, remember, and the height of the image would be negative when if you have concave mirror. Then here this would be negative and this would be positive. We will see reason behind it, don't worry. Directed incidence light. The object is always placed on the left of the mirror. This is side left of the mirror, and light from the object falls from the left to the right. All distances parallel to the principal axis are measured from the pole here. All distances measured to the right of the pole as taken as a positive. This positive. Okay. All distances measured to the left of the pole are taken as a negative. The height measured upwards perpendicular to the principal axis is taken as a positive. The height measured downwards perpendicular to the principal axis is taken as a negative. We know this. What about this negative positive? It is happening. Can we say here it becomes a small? We will see it later. This is negative and this is positive. This is image concave mirror. This was Cartesian sign for a spherical mirrors. Next, mirror formula for a spherical mirror. We have this for spherical mirrors. The mirror formula for a spherical mirror is the relationship between the object distance. Object distance would be called as u. U would be object distance. U v. So first object will come, then image. So image distance would be v, and the focal length would be just first letter f. The mirror formula is expressed as 1 upon b plus 1 upon u. You will get 1 upon f. here 1 upon b plus 1 upon u, u 1 upon u, you will get focus 1 upon f focus. This is just a formula. We will apply this formula on numericals. B. Magnification for a spherical mirrors. Magnification for a spherical mirrors is the ratio of the height of the image to the height of the object. First we will take height of the image h1 and then height of the object. From this you will get magnification height of the image then height of the object. The magnification is also related to the object distance and image distance. It is expressed as h1 and h0. This v and then upon u. In this we will take this minus because of b not b but u is a minus, u is a minus in u is a minus. Reflection light. We have reflection light. Refraction, not a reflection, refraction. We have this much, don't worry, all things will be covered. Refraction, a spherical lens. A reflection of light. Here we can see what is the reflection of light. In this we will realize the medium. To realize the reflection of light, you should have a object medium which should be liquid. When light travels obliquely from one transparent medium into another, it gets bent. This bending of light is called just bending of light is a refraction. Of light. If you are realizing bending of light, just you can say this is a reflection of a light. Reflection, not reflection. Reflection. When light travels from a rare medium to the denser medium, denser we will see. Rare would be a medium which has a less rare. A speed of light would be more, and in denser medium, a speed of light would be less. This is what is the meaning of a rare medium and denser medium. It bends towards the normal, and it will come when a light will come from the rare medium to the denser, then it will bend towards the normal. But what if a light which will come from the denser and then to the denser to the rare, then what will happen? Then it will bend towards the surface, towards the medium. When light travels from a rare medium to a denser, then it bends towards the normal. When the light travels from a denser medium to a rare medium it bends away from the normal. So in other words, you can say it is a bending towards the surface of the medium. This is how happens. This is what happens when a light is traveling from denser to the rare. Then a reflection ray will bend away from the normal line. But a light which is traveling from the rear to the denser, then it will bend towards the normal. This is what will happen. Now next we have here, we are going to visualize it. Carefully visualize it. Reflection of light through a rectangular glass slab. We have this rectangular glass. This rectangular glass. It is what transparent. It is possible to observe refraction of light when we will have a transparent object. If you take a opaque object, then it is not possible at all to observe reflection of light with the help of opaque object. When a ray of light passes through a rectangular glass slab, okay, through a glass slab, it gets bent towards at the twists at the air glass interface and at the glass air interface. The emergent ray is parallel to the incidence ray and is displaced through a distance. What is happening? Here this is normal line. This is a normal line, and this would be considered as incidence ray. This is a ray which is coming directly from the source light, and it is a ray which is passing after crossing the medium. And here we this outward of this glass would be known as air medium, and inside this would be known as glass medium. This would be known as glass medium. Angle of refraction. This is a refracted ray which is bending towards the normal. Between this will be known as angle of refraction. Now a ray which is incidence ray and till the normal line, this between this will be known as incidence ray. This will be known as angle of incidence, not this. We are talking about this. So remember, this would not be equal to this. This would not be equal to this. This would be something else, and this would be something else. If this is 70, then it would be 90 minus 20. It would be 20. I think it should be 20, but I am not confirmed. But yes, I can have. I am confirmed to say that yes, this would not be equal to this. Refracted ray. This is refracted ray. After bending, whatever a ray is coming would be refracted ray. Rectangular glass slab. Yeah, this is a rectangular glass slab. Now here you can see this bent after passing the medium. Then again it passed medium. From here you can see rear to denser, then denser to rear. 2 times bending of. You can see bending of light 2 times. So in this case here a speed of light is more, but here a speed of light became less. Now it traveled in where dense in a rear. So that's why in a rear a speed of light would be more. So here this is a more, and it is towards the normal line. It is not towards the normal line. It is far away of the normal line. Because of it is in a rear. That's why emergent ray. This was about we visualize in this laws of refraction of light. We will see this. We will discuss about it later. Don't worry. In details will be discussed about it. But for now, that's all.